All right, so now that we have the general idea of how to solve a linear equation, we're going to look at using algebra to solve word problems. That is, trying to set up an equation and then just solve it to solve a word problem. Now, earlier in chapter 1, when we were trying to solve problems, we might have drawn a diagram, we might have done some guessing and checking. Sometimes there was a little calculation we needed to make. So the whole point of this is that if you know a little bit of algebra, you might be able to use it and then try to set up an equation, write down an equation, and then just solve it, okay? So a general process is being described here for how to come up with the equation and then how to use it to solve the original problem. So you're going to read it, but as you're reading, you might want to jot down the information you're given and also see what it is they're asking you to find. You know, what are they asking you to do? If you can draw a diagram, if one, like the tomato problem, or if it involves something like a rectangle or a circle, you might want to draw a picture. That can sometimes help. All right. Now, what we're going to do that's a little different than what we did in chapter 1 is we're going to try to let a variable like an x stand for one of the unknown quantities in the problem. And usually you're going to let it stand for what they wanted you to find. Okay. Then you're going to write an equation based on the information they give you. Okay. So you're going to look for quantities in the problem that you might be able to decide are equal to one another. And then after that, all you're going to do is solve the equation and then just check it in the original wording of the problem. Okay? Solve the equation. Then make sure you actually answered the question they wanted you to answer. Sometimes there's a follow-up step. And then check it to make sure it makes sense in the words of the problem. So these two steps are what are kind of different from what we did in chapter 1. You're trying to mathematize it. You're trying to get a variable into the mix somehow, okay? So there are some word problems that require you to think about. Let me get this onto a new page. There are some word problems where you're kind of just translating from the English words into the math. Those are not my favorite type. They're kind of contrived, but it's, I guess, a good starting point. And so this table is one you might want to refer to if you're doing a problem like that. Let me jump ahead and show you the type I'm talking about. If you're trying to solve a problem that says 8 times a number plus 3 is 27, or the difference of twice a number and 8 is 20. Questions like that require you just to pretty much translate from the English to the math, and this table can help you with that. So they're talking about things that you see that are going to tell you that addition would be the appropriate thing to do. So on these, we're letting x be some number. So x is just some number. So if it says you need 6 more than a number, then x plus 6 would be the expression. Or if you had a number increased by 8, you could use x plus 8. 5 added to a number, x plus 5. And then the word sum means addition as well. So the sum of a number and 17. Okay? Now, subtraction is trickier. So is division. These two are the tricky ones because the order will matter. Where with addition, whether you said 3 plus 4 or 4 plus 3, you get the same thing. But with subtraction, 4 minus 3 and 3 minus 4 are not equal. So you have to watch it. You have to read more carefully and kind of hear why things go in the order they go in. Here on this first one, we had 18 decreased by a number. So we'd need the 18 first, and then we'd subtract the number from it. So 18 minus x, not x minus 18. Okay. 6.5 less than a number. Whatever our number was, we'd have to subtract 6.5 from it. 3 subtracted from a number. So it has to be x first minus 3. And then difference is kind of like the word sum, but it means subtraction. When you're dealing with sum, difference, product, or quotient, the order you write is the order you see the word. So the difference between a number and 5 would be x minus 5. The product of a number and 19 is really x times 19, but it means the same as 19x. The quotient of a number and 6, x first divided by 6, okay? All right, so with multiplication, they might say 8 times a number. If they say twice a number, that means the same as 2 times a number. It's like actually supposed to be an abbreviation for that. 2 times a number. That's 2x. And 2x means 2 times x. A number multiplied by 4, okay, even though you might be thinking it's more customary to put the 4 first, and with multiplication it didn't matter. You could do it either way. And then 2/3 of a number would be 2/3 times x. Now with division, got to be careful about order, and there's lots of signs. Oh, let me go back to multiplication for a minute. If I wanted to say 8 times x, the best way to do it is just 8x. When there's no apparent symbol in between two things, it's understood to be multiplication. But it could be written like that, or with 2 sets of parentheses, or with an asterisk. But once you're starting to do algebra, you typically don't use that old-fashioned x, because see how that would be confusing? So that's why a lot of times calculators will have a symbol that looks almost like the asterisk. I think that's what mine looks like. Yeah, so that it doesn't look like an x, okay? All right, now division, saying a number divided by 5, that's what you could write. X first, divided by 5. Excuse me. Or you could do x on top of 5. That also means x divided by 5. My calculator shows it horizontally like that. All of those mean x divided by 5, okay? All right, so 35 divided by a number has to be 35 first divided by x, but it could be written in any of those forms. And then quotient of a number and 6 would be in that order, but it could be written x over 6, okay, instead. All right, let's practice just with that part, just that translating of an English phrase into a math expression. These will not have an equal sign in them yet, because there's no word that stands for equals. It doesn't say is equal to something or just an is. So all we're doing is practicing with what was in this table right here, okay? Just trying to translate. So if we needed 14 times a number, we could just write 14x. I'm going to let x be my number. So I'm going to use x. I could have used an n or different numbers for each of these if I wanted to. A number divided by 7 would have to be the number first divided by 7. Could be written like that, or it could be written like this. Right now, on the next one, there's more than one thing going on. I need 10 more than the product of 8 and a number. So once you do a quick read of it, what you want to do is look for where the variable is referred to, and think about that being an x. Then you back up until you hit an operation word. Don't stop at and. Don't stop at of. Those aren't operation words really in this case. You're going to go all the way back to where you see the product of 8 and a number. So start with the variable being x for number, and then back up and translate the product of 8 and a number. So that would be 8x. Okay, now you're going to continue backing up, and now you need 10 more than that. Okay, I don't know why it all of a sudden changed. Okay, so we just did the product of 8 and a number. So let's please try this approach. It really helps. Start with where the variable is referred to. Now back up and do the product of 8 and a number. And now I'm going to do 10 more than that. So that would be adding 10 to it. Okay. All right, now on the next one, it says 3 less than 4 times a number. Okay, so I'm going to start with the number being x. I'm going to back up until I hit an operation word. I need 4 times that. That would be 4x. Then I'm going to back up, and I need now 3 less than that. So if I need 3 less than something, 3 less than something, then I need to subtract 3 from it. That's it. It's not okay to say 3 minus 4x. Now on the previous question on C, some of you may have said 10 more than the product of 8 and a number, and you would have lucked out. This is really what it says, but those wind up having the same value. But on D, if you were thinking 3 minus 4x, that would be incorrect. Start with the number being x, 4 times it would be 4x, and then back up 3 less than some quantity, you'd have to subtract 3 from it. Okay, and then one more. 6 times the sum of a number and 18. My first read is just looking for where they refer to the variable. I'm going to let that be x. So now I'm backing up to an operation word. I need the sum of a number and 18. The sum, that's x plus 18. Okay, now I'm going to back up and do 6 times that would be 6 times that quantity. I'm going to need parentheses around that for it to say what I mean. This is not correct. 6x plus 18, no, that's not the same thing. That would be the sum of 6x and 18, not the same. Okay, so start with the number being x. The sum of that and 18 would be x plus 18. And now I'm going to back up and do 6 times that and get 6 times the quantity x plus 18. Okay.